Hello, my friends, and welcome to Zero to Juniper class. I am Arpit Pandit. I will be your trainer for this Zero to Juniper journey, and I'm very excited for this because this is going to be amazing. Now, what I have seen in my networking career of last 15 years is that Cisco has always been prevalent in putting out the technology and explaining you how things work, and some of the best documents you can get on Cisco site. But Juniper is one of the technology or one of the company which creates very nice products for routing and switching and security. But their documentation, I would say, is not as prevalent as Cisco. So we decided to create a course where you can learn Juniper from scratch, from zero all the way to the JNCIE level, the expert level, which is the pinnacle of learning Juniper, right? And the objective here in this course is to make sure that you understand starting from the basics, and it is a very heavily hands-on course. That means you will learn all the things right from the first day using the configuration, right, and using the devices. So we will start today with the basic introduction to Juniper, their devices, and the basic CLI of Juniper router. And then later also we will move on to understanding the switch infrastructure, because this course will mainly concentrate on the routing and switching part of Juniper. So there are security devices also in Juniper like SRX series, but those will not be covered in this. It is only purely for going for the JNCIA enterprise or the routing and switching part of it, right? Now in Juniper, there are of course some resources available, but they are scattered. So we wanted to create something which is like a one-stop go for all your requirements. So without wasting any more time, let's get into Juniper. Let's jump into it, and let's see how we are going to start. So the very first thing is that in this course we will be doing all our practicals using a software called EVNG. So if I show you how does EVNG look like. So EVNG is something we also use for our Zero to CCI course, which is also a milestone for Cisco CCI certification. But in this particular course, we are going to use it for Juniper as well. And we are going to use the MX series Juniper routers, which are very high-end routers. And as you can see that it shows two routers at one place, but actually it's a single router. The VFP is your data plane and VCP is your control plane for every router, right? So they are connected, and you will always configure the control plane device, the VCP device. The VFP is just to send and receive traffic, and you will understand it more. So we will provide you the OVA file, which you just need to import in any VMware or any virtualization software, and you will be good to go, and you will be able to configure all these things. I would suggest you to have at least 16 gig of RAM in your laptop or your desktop. With 8 gig of RAM also you can do some of these things, but as soon as we start progressing towards the specialist or professional level certification or the expert level configuration, you will see that more and more devices might be needed, and it's always a good idea to have 16 gig RAM at least, right? So with that information, let's get back to our topic, Zero to Juniper. Now one thing you will see is that the whole Juniper ecosystem actually revolves around the Junos operating system, the Juniper operating system, also known as Junos. So it's actually based on FreeBSD Unix. So it's a Unix based operating system. But what makes it unique, or what makes it very stable, is the compartmentalization of different services. So every process runs in its separate protected memory space. So that means if one process fails, it doesn't affect other processes and doesn't crash the system, right? Also, adding new features or new processes do not affect the existing features. So that's a really useful thing in case if you want to practice something, or you want to test one process and it crashes, it doesn't take the whole system down. So very useful thing, and now other vendors are also adopting this. And another great thing about Juniper is that irrespective of whether you are using a routing device of Juniper, a switching device, or a security device, the same source code is used for all models. So same source code for all platform specific images. That means many features and services are managed in same way. at least at the core point. Of course, the switching devices will have different set of commands for switching, of course, comparing to routing devices, and then again comparing to security devices. But the core is same. So many of the features and services you can configure unanimously and in the similar way on all different kind of platforms. So that brings us to a very important point, as I showed you into the EVNG, that there is a control plane and there is a forwarding plane, right? So there's a very clear separation between these two. Just like, you know, in software defined networking, we have a control plane device, and then there are different forwarding plane devices. In Juniper, they have already been using this concept from beginning. The only difference is that they do not have a centralized control plane. Every router or every switch or every security firewall has a dedicated control plane and data plane engines. So as you can see that they are called routing engine and the packet forwarding engine. So the routing engine is the control plane where actually all the configuration and all the routing protocols, all the policies are defined, and that's how it actually populates the routing table. As you can see, the RT, the routing table is created. And then once the routing table is created, to find out where to go, what is the best path to go somewhere, this routing table is copied into something called a forwarding table, and then it is sent to the forwarding plane. And there is a dedicated internal link between your control plane and forwarding plane, and this link is used to copy the forwarding table to the forwarding plane. So the Junos operating system takes care of that copying. The best thing about this is that all the process level configuration and all the processing happens on the routing engine, and the results are copied to the forwarding plane. And the only thing forwarding plane has to do is to forward the frames or packets. So you can see here frames or packets coming in, frames or packets going out. So this is just switching the frames as fast as possible, and that actually takes the performance to another level, right? And another thing you need to understand is that of course there will be a processor who is managing the routing engine, but for the forwarding engine or the packet forwarding engine, there are dedicated co-processors called ASICs, application specific integrated circuits, and their only duty is to receive frames and send frames, receive frames and forward frames. So it makes them really fast, because these ASICs are not bothered about the user configuration, not bothered about the routing updates, neighborships, anything. This all is managed by routing engine, right? So it is only going to forward the frames. And the best thing is that once you copy the routing table as the forwarding table into packet forwarding engine, then it can use it to decide or take action on the packets based on their source or destination IP addresses, right? That means when the frames are switching, when the frames are going through the router, it doesn't need to go to the routing engine. So it doesn't affect or it doesn't interfere with the main processor, right? It doesn't actually create an exception for that. So all the traffic passes through the forwarding packet forwarding engine using the ASICs, application specific integrated circuits, without disturbing the routing engine or without creating any interrupt for that, right? So that actually brings us to two types of traffic that a router can receive or a Juniper device can receive: transit traffic or exception traffic. So the transit traffic simply means that the packets are coming in and they are not actually destined for this device. They are just passing through this device. So these kind of packets or frames are immediately and correctly, accurately forwarded using the forwarding table. So in that case, you do not interrupt or do not disturb the routing engine. But then there is exception traffic, which actually includes the traffic which is actually destined for this device, maybe the telnet session, secure shell session, or routing protocol updates which are actually sent to this device. These kind of traffic is actually then received by forwarding table and sent to the routing engine. So the packet forwarding engine, PFE, receives it and send it to the RE or routing engine. So exception traffic is the only one which needs to go to the routing engine. Every other traffic, which is the user traffic, data traffic passing through the router, is completely managed by packet forwarding engine. So that makes it really amazing. And packet forwarding engine is your data plane. So you might have heard these words also before, like we have different kind of packet forwarding engine hardwares which we can insert or remove from the router. If especially if it's a high-end router, you will have many different packet forwarding engine yeah, cards. We call them the data cards, right? So these cards can be inserted or removed, and that way you can have more or less capability or capacity to forward traffic depending on the different types of router models or switching models or firewall models you are using, right? Excuse me. And the routing engine also, that's the brain of your router, which is making all the decisions. So to have redundancy, you will see that high-end routers also have two routing engines, primary and backup, so that if the primary routing engine fails, the backup routing engine can be used for that purpose. And this separation also helps you to keep forwarding the traffic even if you lose the connection to the routing engine. So if the packet forwarding engine loses the connection to the routing engine, it will still be able to forward the traffic because it has the copy of forwarding table. So the temporary disconnection between routing engine and packet forwarding engine is not going to impact your traffic forwarding capabilities. Another thing you will notice is that in case of routing engine and packet forwarding engine separation, you can actually create, you can reboot your routing engine, and your packet forwarding engine can still keep on forwarding the traffic, which is called the graceful routing engine switchover or graceful restart. Also, if you want to upgrade your router, you can upgrade some of the softwares in your router, like which is called ISSU, in software, in system software upgrade or service upgrade, and that allows you to still keep on using your forwarding engine to forward the traffic while your routing engine services are being upgraded. So you can see that gives you a lot of benefits. So that brings us to how many different types of devices are there in Juniper. So we have routing devices, of course, routers, we have switches, and we have security devices like Juniper, SRX firewalls or J devices. So routing devices, first of all, if you see, there are many different types of routing devices depending on what you are doing. So for example, ACX series devices are used into data centers. LN series are very hard rugged devices which you can use in outside environment. They can endure high temperatures, rains or harsh winds, so they are created for outside implementation. And then comes the routers which can be M series, MX series, PTX series and T series. So in that order, depending on how big or how huge your implementation is, you will be using these routers. Like M series routers are also high-end routers which you can use in your network as the edge devices, connecting to WAN or connecting to MPLS services. MX series is same, just with the higher capabilities, more capabilities, more power. PTX series devices are packet switching, package transfer switches, and these are very high-end devices which you can use in your network enterprise core with high throughput. And T series devices can be used into the biggest of implementations like service providers and all, and they can handle huge amount of data in terabytes per second for that purpose, right? So in our course throughout, we are going to use M series or MX series devices because even in some of the considerably big organizations, they can perform very well, right? Comparing to switching devices, there are EX series devices and QFX series devices. So EX series devices are your switches which you can use in your enterprise networks, and QFX series devices are used into data centers, just like Nexus, Cisco Nexus series. It's comparable to that. And comes the security devices. So we have J series routers or firewalls, you can call them, and SRX firewalls. So SRX firewalls are very high capability firewalls which can support VPN services, open SSH services. So a lot of security services and VPN connections are supported. But for this course, we are going to concentrate on the routers and switches, right? Because this is a routing and switching course. So let's talk about the user interface now, because when you boot a router or a switch in Juniper, how do you access it? So there are two methods of accessing Juniper device: CLI, command line interface, or using a web-based HTTP based browser based connection called JWeb. So in this particular video, we will talk about the basic CLI configuration, and then later we will also see how to use JWeb in upcoming videos, right? So let's talk about CLI. So when you boot a Juniper device, a Cisco every time, because we use Cisco more than that comes in most of the time. That's what I say instead of Juniper. So that actually also tells you that the Juniper is not that much exposed, right, into the training field, and that's why we wanted to create this program. So there are two types of users you can create into Juniper Juno's CLI. So when you boot a Juniper router or a Juniper switch, the very first thing it will ask you is the authentication, that who are you and who is trying to access this device. So there can be root users and then there can be non-root users. So the root user is the one who has the complete control and it has all the credentials and all the power. And when the root user log in, he is actually placed into a shell, and then he must type the keyword CLI to start using the Juno's CLI. So the CLI keyword has to be typed. So the shell prompt is represented with %sign, $, as you can see here, %, and you type the keyword CLI to get this greater than sign. This greater than sign represents the CLI prompt. That's where you start configuring the Juno's device. If you are a non-root user, then you will directly be placed into the CLI prompt when you use the authentication. So let me show you this on the devices. So we can see that we have two devices here, VCP1 and VCP2 control plane. Again, we do not configure the forwarding plane. We configure only the control plane, and the control plane uses this internal link em1/internal to send this information to the forwarding plane to start connecting them. Like I'm using a simple topology here, connecting two Juniper routers using gigabit Ethernet 0/0/0, right? So let me show you that. Let's say I go to VCP1. So one thing you will notice is that if it's a completely new box, you will see something like this, where the name will be Amnesiac. That's the default host name if you have not configured anything. If you change the host name of your device, it will represent here, like in this case, R1. So in VCP1, I have changed the name to R1. VCP2, I have not changed the name. So I will show you how to change it. Now in case of VCP2, it's a completely default box. That's why by default, the only user exists is the root user. So you can type the username root, and you can see that it does not ask any password, because by default the root user does not have any password if you are using a factory default setting. And you see that when I use the root, it actually leaves me to the shell, right? And you need to type CLI to get to the configuration mode. You can see here, now I'm in the root, and there is no host name, so it just shows the keyword root. That means the user, there is no host name configure. Same thing here, I can type the username root, but you see this time it is asking me the password. Why? Because I have configured a password, a non-default password for the root user. So I have used the password Karotul, and when you type the password, it doesn't show you, and you can see now I'm in. And the difference you see here is that in the case of default configuration, first of all, it doesn't ask you any password, and second thing, there is no host name. So root at, and there is no name. But here, first of all, it is asking me the password, I configure it, and then root at R1, because I configured the host name as R1. But still, I'm still into the shell, so I need to type the keyword CLI to get into the router configuration, and that's where we can start configuring this device. So before we start jumping to the configuration and see how different things are configured here, one thing we need to understand is that what are the different syntax and what are the different things we can do, and some of the very unique features of Juno's operating system, so that we are equipped with that information before we start building the basic configuration. So into the next video, we will see the basic configuration build-up. But right now, let me just explain you some of the basic things in the Juno's operating system. So the very first thing you will notice is that this prompt here, the greater than sign prompt, this actually represents the operational mode. So this is called operational mode. And on this mode, you can use some monitoring and troubleshooting commands. So you can use monitor command, which is used to monitor the traffic or a different aspect of the device. You can also use ping, trace route, your normal checking commands, ICMP commands. You can also use the test command to test few things here and there. So these are some of the basic commands which are not configuring anything on the device. So the configuration actually happens under the configure mode, and the configure mode you actually go through with the command configure. So you type configure, you press enter, and you can get into the configuration mode. So you can see that the configuration mode is represented with the hash sign. So greater than sign is the operational mode. You cannot configure anything here, and the hash sign is the configure mode where you can start making changes to the device. This is the configure mode, and in the configure mode also you can go using either the command configure, or you can use some other commands we will see in few minutes, right? So let's go back to the thing. So as I said that you have to type the CLI to get here, and then there are two modes, right? Operational mode represented with the greater than sign, where you can use monitor, ping, show commands, all the show commands, test, trace route, these things, and this is an example of that, right? On the other hand, the configuration mode represented with the hash sign or a pound sign, where you can configure all the things on the device, right? And in the CLI you can also use different help things, where you can use the question mark or the help command, spacebar to complete the command, or tab to complete the command. So these all things are supported here. For example, if I'm here and I type the show command, I don't know what actually I can check. Let's say show OSPF, one of the routing protocol. But what can I check about OSPF? I can put a question mark, so it will tell you what are the different options. You can check show OSPF neighbor, show OSPF route, show OSPF database, show OSPF interface, and so on, right? So this you can do. Let's say you type the keyword IO, and then if you press tab, it is going to complete it for you. Or you can also use a space bar. So if I press space bar, it's the same thing. It can complete the command for you, right? And you can also say help topic, let's say OSPF, and let's see. Okay, specifically what do you want to know? So let's say OSPF metric, and then you can press enter. So it will tell you the details about the metric, like what is the OSPF metric and where do you configure it, overview of it. It's just like a documentation, right? And how to use it. So it gives you an option also, and then specify what you can do with that thing, right? Results and all things. So set protocol, OSPF, interface, metric 5. So it's a very, very detailed document if you use the command help topic, right? On the other hand, if you use the command help reference, let's say OSPF metric, just to give an example, metric, then it will give you different examples that how you can set this metric with the different commands. So this is a very, very useful feature. So you can use different CLI help like this. And then of course we can use the pipe command. So the pipe command is to actually filter the output that you are using. Like for example, some of the interesting things are you can use count. You can count the number of lines that you are typing, or you can use display set. If you don't want to see the output into like a programming language output like XML format or JSON format, you want to see it into the normal command format, set command format, you can use display set. If you wanted to see it into the XML or netcon format, you can use display XML. So there are different options here, right? And again, you don't need to remember all of these right now, because we will be using them at different times, and we will be explaining them in more detail. But some of the examples, if I show you, for example, if I run show configuration, so it shows me the configuration in this format, right? System, curly bracket, route authentication, this is the password, host name R1. So this is called the Juno's standard output of the configuration. So it is not showing you the configuration the way you configure it. Like I configured the host name with the command edit system hostname R1. So it's not showing you in that way. It's just showing you under the system we have a configuration hostname R1. Under the system there is another keyword root authentication, and I configured a password there, right? So it's showing you in this particular method. So what you can do is you can use the command, for example, pipe display set. So show me into the set output, means what are the commands used. So you can see that it is showing me now in the proper configuration. I use the command set system hostname R1, set system syslog, and also, right? Root authentication it doesn't show because that's not a normal set command. It asks you interactively what password was there. So the pipe can be used to modify the output according to you. Like I want to know how many lines are there, so I can say count, it's a 40 lines, or I can use display set and count. So you can see you can cascade the pipe command as well, and it will show me there are only 12 lines, which we can see here. The 12 lines were there, right? So the root authentication, root authentication is there. Okay, so it is showing me the password before that. So pretty nice, right? We can use this to filter the output. You can actually use some interesting outputs also. You can see like display XML. Let's try this display XML. So it will show you in the XML format, which you can use to actually do the programming and use netconf to configure the device. Most of these you will not use on a daily basis, but good to know the complete list, right? For example, you can use regular expressions to filter the output that you want, right? So for example, let's say again, let me show you display set. So this is like configuration. Then I can say accept regular expression. Sorry, the regular expression itself. So what do I want to remove? So let's say I don't want to see anything with the keyword file. So I will say accept file. You can see that now anything which has the keyword file is removed from that. So accept file. You can also use match keyword here. So the match keyword allows you to match a specific value. So match file. So now it is showing me only the output which has the keyword file somewhere in it, right? So this way you can use this for a different purposes, right? Now apart from this, there are some other also, like you can use find, and you can find you can start displaying the output from the first occurrence of that particular keyword. So let's say that I want to start showing the output when the keyword interactive comes into the picture. So it will start showing me the output from that line, and then everything else will be shown. So I can say find interactive, and you can see that it finds it the first occurrence, and then everything else is also shown here. So it's not just going to show you the keyword where you find the keyword interactive. If you want to just see the lines where the keyword interactive is there, you use the match keyword, right? Not the find keyword there. So we can use find for that purpose. And then there are many other things like match, as I mentioned earlier, can be used. No more, if it's a lot of configuration, what happens is that by default Juno shows you the output one page at a time. So you can press a space bar or enter to see more. But if you want to see the complete output without stopping, you can use the keyword no more. And the output can also be saved to a file using the command save file name. So these are some of the examples here. So for example, let's say I say show configuration save let's say current underscore config.txt. So this file will be saved, and this file is saved into your root directory because you are a root user. If you are a non-root user, it will be under /var system, right? So these are some of the pipe options you can use. Now one of the very important topic or very important concept of configuration before we move to start configuring device is that there are two types of configuration into Juno's operating system. Active configuration, that means which is currently active, and the candidate configuration, which you configure and the changes that you make. So unlike other vendors like Cisco, in Juno's operating system or Juniper, when you configure something, it is not immediately committed. It is not immediately configured. It's actually stays into something called the candidate configuration, and it's not active. So when you start configuring the device, it keeps the configuration into candidate configuration, and only when you use the keyword commit, then it is copied to the active configuration. You can see that whatever you configure is in the candidate configuration. It's not active yet. It's not changing anything on the device. It's not impacting the device. And as soon as you do the commit, it is copied to the active configuration, and the active configuration has a number 0. So it can your system actually can keep up to 50 configurations, including the active configuration. So 0 to 49, right? So when you configure something, it is placed into the candidate configuration, and you can use the commit command to make it the active configuration. And let's say you made some changes, you committed it, then you made another changes, you committed it, you made another changes, you committed it. So every change that you make and you put the commit command, that changes goes into the rollback configuration. That means it is the last 49 configuration changes you made and committed will be kept. So you can actually go back to your earlier configuration using the command rollback, and then you can type the number. Which number do you want to go to? Rollback n is the very last thing you did before commit. Rollback 1 is the very last thing you did before commit. Rollback 2 will be the configuration which you did 2 commits before, and so on. You can do the rollback as well. So this is a very useful thing. If you make any mistakes into your syntax, it will not commit the configuration. It will tell you the error right away. Also, it gives you an option to check your configuration, what you did before you committed, right? Because once it is committed, it becomes active and it is going to impact your network. So just to give you an example, let's say on this second one we don't have any host name, so I want to configure host name. So you do the this is the operational mode. We cannot make any changes here. So I type the command configure. I go into the configuration mode. You see the prompt changes to hash. So what I want to do is I want to change the host name, and host name is under the system configuration. So there are 2 methods of doing this. One thing is I can use the command edit system host name, and I can type the host name here, right? So the edit system, and press enter, and you can see that I was on the root level, and then I go into the system level, and now I can actually use the command set host name, and then I can set the host name because I am under the system hierarchy. So I can set the host name to R2, for example. And when you do this, you can type the show command, and this show command is different from the operational mode show commands. This will show you only the content from the hierarchy you are currently in. So whatever is configured under the system hierarchy, it is going to show you that. So if I just type show, you can see that it is showing you what is currently there. So it was this is the configuration which was there, and this is the new configuration which I just added, hostname R2, right? And it is giving me an error also, that missing the mandatory statement root authentication. What happens is that as soon as you go as soon as you change anything from the default configuration, like in the system I set the host name, then it is not going to take the default root authentication, which is no password. There was no password, right? It says that you need to configure a root authentication password here. Without that, it will not work. But you can see that one method was edit system, and then we use the command set to set everything inside this. So you can see we go into the hierarchy, and then we set things inside that hierarchy. Another method would be, by the way, I can use the keyword up to go one step up into the hierarchy, or I can use the keyword top to go directly to the root hierarchy, which is this one, edit, right? So I can also set the host name using the command set system host name and R2, like this. This is the same thing, but you see that in this case I don't need to go under the hierarchy. I directly can set it from here if I know the complete path. So the set command can be directly used as well. Now if I show you the show, because I am running the show command directly on the root hierarchy, it is going to show me the complete configuration of the device. When I run the show command under the system hierarchy here, it was only showing me the configuration of the system hierarchy, right? So you can see here, it is showing me the host name is R2. By the way, it is also showing me all the configuration which was already there also, plus what I just configured. So how can I check the configuration which I just changed? I just want to know the changes that I have made. So what you can do is you can use the command show pipe compare, and you can see that this one I'm using inside the configuration mode. So this is a very, very useful command. It actually shows you the comparison between the current configuration, active configuration, and the changes that you have made, which is the candidate configuration. So you can see that currently in the candidate configuration we only have hostname R2, and the plus sign means that this is going to be added. If I go ahead and remove something right now, it will show you with the minus sign, right? So the hostname R2 will be added. So let's go ahead and also set the root authentication password. So I can do edit system, and I can press enter. Inside the system I can say set root authentication plain text password, and I want to set the password to Karoto. right? Okay, sorry, this one actually takes it like this, and then it asks you the password. So I can type the password karotu. Again, the new password is set. So now if I check show pipe compare, you can see I change the host name to R2 and I change the root authentication password to Karotul, but it actually shows always you into the encrypted format, in the secret data format. Now I want to save this. It's not saved yet. You can see I am still seeing just the root, not my host name. So that's why you use the commit command, right? So if I do a commit, you can see that commit completed, and see the difference before commit and after commit. Now it is showing me the host name R2, right? Now if I do a show pipe compare, it doesn't show me anything. You know why? Because there is nothing into the candidate configuration anymore. We did not make any new changes, right? And the changes that you have made are gone into the active configuration, which is the configuration number 0, right? So this is a very useful thing to do. And let's say I change the host name again, just to show you an example. Set host name, and if I'm not into system hierarchy, I'm here root, then I have to type set system host name. But since I'm already inside the system hierarchy, I can just type whatever inside we need to configure. So let's say I want to change the name to R10, whatever, right? Now if I do up, go back to the main hierarchy, edit, you can see, and then if I type show compare, now I can see that it is going to remove R2 and it is going to add R10, right? So let's do a commit just to show the example. So commit completed, right? Now let's say I exit from here, go back to operational mode, and then you can see that I can use the rollback command if I want to roll back to the previous configuration. But I want to compare it first. So what you can do is you can use the command show configuration compare rollback. So which rollback do you want to compare? So rollback 0 is the current configuration, active configuration. So there will be no difference, right? But if I do a rollback 1, that means what was there before I committed. So before I committed, there was R2. The host name was R2, right? Not R10. So if I do this, you see that this is what happened. So in the last commit, I removed the R2 and added R10. Okay, what did I do before this? Rollback 2. If you remember, before this, we set the root password and we set the host name to R2. And that's exactly what it shows us, right? So root authentication was there and host name was, sorry, R10. And I think it was in rollback 3. Rollback 3 is the older one. Okay, so host name 2 that we did, it is not showing into the rollback 2. It is directly showing the host name R10. I think it should show R2 because that's time we did the R2 configuration. Let me do one thing. Let's say I go to configure mode and I do a rollback to second one, this one, right? Let's see what will be rollback. And remember, when you do a rollback, it doesn't immediately make it active. It loads it. It's in the candidate configuration, but you have to commit to set it up. So let's see, show pipe compare. This is what will happen, right? The root authentication will be gone, and then the host name R10 will be gone, right? So if I do a commit, let's see, and of course, as soon as you have any host name, it is not going to let you remove the root authentication. So it is going to give me an error that you cannot remove root authentication. So one good way before you commit is always to do something called commit check, and it will tell you what will be the issue if you try to commit this configuration. So how do you remove this error? You can always do a rollback 0. That means go back to the same configuration I currently have. You can see now it's okay. You can exit the configuration. So this is important to remember. Whenever you make any changes, you have to use commit command to make these changes permanent. That means the active configuration. But the previous changes are also kept. Last 50 changes are kept, which you can go back to using the rollback and the number command, right? Now, when you configure the device, as you saw me going into the configuration mode with the command configure, but there are 3 options here. We can use configure to get the control of the device, or we can use the command configure exclusive, where we exclusively get the access and no other user can access this device, or we can use configure private. Now what private does, it allows you to make changes, but at the same time some other user can also log in and they will have their own candidate configuration. And as long as you do not have any conflicting information between these two candidate configurations, they can be committed separately. And of course, the one which is committed last will become the active configuration. So you can always use any of these three options. I would always suggest you in the production environment use configure private, so you do not impact any other configurations. Now, talking about hierarchy, as I mentioned earlier, we can use either the edit command or the set command to configure things. You can see, for example, edit protocols, OSPF, area 51 stub. So you can see under the edit, you can set chassis, interfaces, protocol, services, system, and so on. And then under the protocols, you can configure multiple routing protocols like RIP, OSPF, ISIS, PGP. Under the OSPF, you can configure area, overload, traffic engineering, many things, right? Under the area, you can configure area range for summarization, interface, which interface it is going to be, and which kind of area it is. So you can see you can go more specific. You can type it like one time, or you can do it multiple times also, like edit protocols, enter. Then edit OSPF, enter. Then edit area 51, enter. Or you can type in the same command. You can also use the set command if you want to set it directly to that value. So both options are possible, right? Now this is the interesting thing, configure mode show command. So as I mentioned earlier, that inside the configuration mode, when you use the show command, it shows you only the information from that particular hierarchy. Like in the system, if I type show, it will show me everything from the system hierarchy, or I can be more specific, like only show me the services from the system hierarchy, and it will show me that configuration into this Juno's standard output format. Of course, I can use pipe display set to see it into the set format where the state set commands are used. Now this is also something we talked about, that if you are inside a specific hierarchy, you can use the up command, and you can use up 1, up 2, up 3, how many steps up you want to go, or you can use the command top. And if you use top command, it takes you all the way to the root hierarchy, edit, and the top edit or top show command allows you to change or show the configuration from other hierarchies while you are into a something other hierarchy. So let me actually explain you what I mean. So let's say I go to the configure mode, and I configure an interface. So I say set interface 000 unit 0 family inet, means IPv4, and then I want to configure the address. So let's say I want to use the address 192.168.1.2/24. Sorry, inet address I have to use, and then 192.168.1.2/24. So you can see that I can use the set command like this, and you can see show compare. It is into the candidate configuration. Under interfaces, I created G000 unit 0. So you have to understand that for using any kind of IPv4, IPv6 addresses, you have to use a specific unit. Directly you cannot configure it on the interface. And then under family inet, I can configure the address. If you want to delete this, you can simply change the set keyword to delete keyword. So delete will remove that configuration what you just configured. So show compare, you can see this information will be deleted. But you see that what did it delete? It only deleted the address, because I said delete this. If you want to delete the complete interface, you will type delete interface G000. If the interface have multiple units, like multiple VLANs, just like sub interfaces in Cisco, you can use delete interface 000 unit 0. If you want to just delete IPv4 family, delete interface 000 unit 0 family inet. So you can see what do you want to delete. More specifically, you can type that. So let's say if I type delete the complete interface, right? So this whole interface will be deleted. Now if I do a show compare, see, nothing has changed because I created an interface and deleted it. But the top command which I was showing you, let me show you that. Let's say I do a edit instead of set. So edit interface G000 unit 0 family inet. So I'm inside this configuration, right? Family inet. Let's say I want to go one step up, I can use up, but I want to go 2 step up, so I can say up space 2. So it will take me back all the way to unit 0. So you can see that up 2 you can see I'm in 000 now in this hierarchy. And if I use keyword top, not tip, it takes me all the way out to the main interface. So let's go back to the inside, and let's say I'm here and I want to configure the host name. I want to change the host name to R2, which is inside the system configuration. So one thing of course I can do is I can type top, go back to the top level, and then go to the edit system host name, right? Or what I can do is I can say top and directly type the command that I want here. So edit system, yeah, it takes me directly there, and then I think use set host name to R2. And if I do now show compare, you can see that the R10 will be removed and R2 will be there. So again I can do a commit and changes will be copied to the active configuration. You can see now it has become R2. So that is something you can do using the top command. So from top you can go to any level using the exit. From top level you can exit to go back to the operational mode, or from any level you can use the command exit configuration mode. So for example, let's say I am you can see I am in the edit system. I am not on the top level. So if I do an exit, I only get out of the system. I don't get out completely to the operational mode. So let's say I do edit. We have here, right? We are inside like this, edit interface unit 0 family inet. From here, if I want to exit directly to the operational mode, I can just simply press Ctrl Z, and then you can see it actually takes me all the way out of the operational mode also. I can type CLI and then configure. Yeah, so let's go back here, edit configuration mode. That was one method. Another method would be to use exit configuration mode, and you can see it takes me directly out even if I'm deep inside that, right? Now another thing is that set and delete. This is something we already saw. We can set we can use set keyword to set some services, delete keyword to delete services. You can also use wildcard delete if you want to delete multiple configuration which has similar starting or similar things like G-1/. So anything is starting with this keyword and then we put asterisk or star, it is going to delete those. So set, delete, or wildcard delete can be used. So some other useful configuration commands that you can use are rename. You can rename an interface or any other configuration from one thing to another thing. And this can be very useful if there are multiple sub interfaces, let's say, and you want to change them all to another one. You can replace the pattern also, specifically like one pattern to another pattern. You can copy the configuration from one interface to another interface, and you can deactivate interfaces. So deactivate command actually doesn't delete it. So we saw that we can use the set interface to set it and delete interface to delete it, right? So when we delete an interface, it is completely gone from the configuration. But what if you want to keep the configuration but just want to shut down the interface? You can use deactivate interface, and it is going to shut it down. Don't worry about these things because we are going to use them again and again into different settings. So it will make more sense once we get more into the details of configuration. We can use insert, especially if there are some like firewall policies which have multiple terms and you want to insert one term above another term. So we can change that. And annotate is just putting a comment. You can actually set a comment somewhere. For example, if I see show configuration, I have interfaces, and let's say I want to say that this interface goes to R1, right? So what I can do is I can go to the configure mode and I can use the command annotate. And what do I want to annotate? I want to annotate interfaces, and the interface that I want to annotate is G000, right? So actually we have to go under the interface hierarchy, edit interfaces, and then I can say annotate G000. And what do I want to say here? I want to say connects to R1, right? And you can see show compare to see what changes we have made. We will add this comment here, connects to R1. And again, this is in candidate configuration, so you will have to use the command commit, so that it becomes the main configuration, and you can actually check show configuration, and you will be able to see here under interfaces it says G000 connects to R1, right? right? Before the configuration, it will show you that. So very useful command. And we have been using commit command to save the configuration, right? But there are many options you have with the commit. So of course you can use just commit to save the changes from candidate configuration to the active configuration. But before committing, maybe you want to check the syntax errors or anything, so you can use commit check. What it does is, instead of committing the changes, it will tell you if there are any syntax errors into your configuration. This is also very useful command, commit and quit. If you use this, then it is going to commit the changes and take you out to the operational mode, the greater than sign mode, right? Sometimes what happens that you are configuring a device remotely and you don't want to lose the access to a device. So if you have configured some things which you fear that these changes might result in losing the connection to this device, you can actually do a temporary commit. Now what is temporary commit? Temporary commit is that you type the command commit confirmed and type the number of minutes, and then you say that if everything works fine, I will type the commit command again in this many minutes. If I don't, please roll back to the last configuration. So let's say I made some changes and I'm a little bit scared to commit it because it might result in me losing the connection. Instead of typing commit, I can type commit confirmed 5. So it is going to expect me to type the commit again in 5 minutes if everything seems okay. So let's say I type commit confirmed 5, press enter, and I do not lose the connection. I check everything properly, everything looks fine. So before the 5 minutes finish, I can type the commit command again to make sure that yeah, my commit was okay. If I don't, then it is going to roll back to the previous configuration, roll back 1. So that's very useful command if you are configuring something where you do not have the console access. And then of course you have commit at, and you can type the time, exactly what time you want to commit if you don't want to type right now. So you can schedule your commit, and if you schedule it, you can check it into the show system commit. That command goes on the operational mode, everything else goes in the configure mode, but show system commit and clear system commit goes on the operational mode. So these commands allow you to check if somebody has scheduled a commit, and if you want to remove that schedule, you can use a clear system commit. And of course show compare shows you the candidate configuration before you commit it, so you can check it one more time. So very useful commands. Now comes the rollback and load. So rollback is something we can actually check on the operational mode. First of all, if you are going to roll back, maybe you want to check what will change in the configuration. So this is something we saw earlier also. Show configuration pipe, compare the rollback, and there are 50 rollbacks, so you can compare your active configuration with any of the earlier saved configuration and see what will change if you roll back. Of course, you can also have some configuration into a file, and you can compare your current configuration with that file and see that if that file will have any differences also. I think we have saved a file here, right, earlier, so we can check that. For example, if I do show configuration pipe compare, and you can see that it shows me a file name if we have a file. So I think it was on router 1. Let me check that. Yeah, that was the file name, right? Current config. So if I check show configuration compare, and then you can see that it shows me the file name here, current config.txt. So of course there is no difference because we did not make any changes here. Let me go ahead and make a change here. Let's say configure, and I say set system hostname R5. I change the name, right? Commit and quit. So the name changes to R5, and now let me compare it with the configuration. So you see that we removed the R1 and changed the R5. This is the difference here between the file. And what if I want to go back to this file, whatever the configuration was there? So you can see here that you can actually use the load command. The load command allows you to load the configuration from a file, and then you can commit that configuration, right? So let me show you that. If I do configure, and then I use the command load, and then we have many options here. I can load the factory default settings to remove everything, or I can use load merge. This is the most important one, because if you merge it, then it is not going to remove anything which is already there. it is only going to make changes which are conflicting or which are new, right? So this is the option which you will use most. If you use override, it is going to remove all the existing configuration and only use the configuration which you have into the current config.txt. So it might be that some things are currently there and not into the current config.txt file, they will be lost, right? So these are the different options we have. So let's say load override, let's do a override, and then we want to use the current config.txt. Load complete, you can check it with the show compare. This is the only difference which will happen, right? But everything else is same. Remember, when you do a load, it does not immediately become active. You still need to do the commit. Let's do a commit and quit, and that will make the hostname again R1. Perfect, right? That's the way we can use this. So that's it for this video. I hope you understood the basic commands. You can go through this video again before we start configuring basic things on the routers into the next video, so that we can become more and more familiar with this context. Thanks a lot, and see you into the next one.